Hi guys, once again let me apologize for the background noise. I'm still at the airport, but we're going to give this a shot again. I want to forewarn you with regards to lesson 3.3. They give you some definitions that are rather confusing, and I'm going to try to put it into plain language as best I can to help you understand a little bit more clearly what some of these terms are and what they represent. So our goals here in lesson 3.3 are to be able to determine if a function is even or odd by looking at its graph, to be able to determine if a function is even or odd by using its equation, to identify where a function is increasing, where a function is decreasing, and where it is constant, to find the local maxima and minima, as well as the absolute maxima and minima, and then also to determine the average rate of change of a particular function. So we're going to start by determining if a function is even or odd from a graph. Well, when you look at a graph, a function is even if when you substitute negative x into the function for x, you get the same y value as when you substitute x in, okay? So in other words, when x is negative 2, y will have the same value as it does when x is positive 2. Now just a little hint. A function that is even is going to be one that is symmetric to the y-axis, like this one, okay? So it has to be symmetric to the y-axis to be even. On the other hand, when a function is odd, when you substitute negative x into the function where you see an x, you don't get y, but rather you get the opposite of y. So again, another hint, what you're going to see when a function is odd is that it's not symmetric to the y-axis, but rather it's going to be symmetric to the origin, like something like that. Oops, that was supposed to go through the origin. Yeah, like something like that, okay? So when x is positive, say, and has a y value there, negative x will have the opposite y value down here. Okay, so it will be symmetric to the origin. And that's what I have highlighted here in this last box. So let's take a look, couple of graphs. Here in A, notice that it is symmetric to the y-axis. Therefore, it is an even function. When I substitute a positive value in for x, I get the same value for y as when I substitute in that negative value. If you look at B, this graph is neither symmetric to the y-axis, nor can I rotate it around the point at the origin, and therefore it is neither even nor odd, because it's not symmetric to the y-axis, nor is it symmetric to the origin. But in C, I think you notice if you were to rotate this graph around the point at the origin, this side of the graph would land nicely on this side of the graph, and vice versa. Therefore, it is symmetric to the origin, which makes it an odd function. Okay, so now we want to be able to identify if a function is even or odd from its equation. And we've actually done this before when we were trying to determine symmetry, okay? So let's look here at A first. In A, we want to see what happens, what we get for y when we substitute negative x in for x. So, hang on a sec. So we have the function f of x is equal to x squared minus 5. And we want to see what happens when we substitute negative x in for x. So this x squared minus 5, now the x is going to be replaced with negative x. Well, when you square anything, whether it's positive or negative, you get a positive value. So negative x squared is the same as x squared. Notice what we get for our output is exactly the same as what we started with. So when we substituted negative x in for x, we got the same y value. That's why function f, is an even function. F of negative x will be the same as f of positive x. I accidentally deleted my function. So here's the g function, and we wanted to determine if this is even, odd, or neither. So once again, we want to substitute negative x into the equation for x. So instead of having x cubed minus 1, we're going to have negative x cubed. Well, negative x cubed is the same as negative x times negative x times negative x, and that equals negative x cubed. So now notice our final output here. It is not the same as the original output in the g function, therefore it is not even, but it is also not opposite of the original g output of the g function. You might say, but it is, Lynette. No, the x is negative, but this negative 1 did not change sign. Everything in that output needs to change sign in order for it to be an odd function. And therefore, function g is neither even nor odd.